Let me go ahead and start this real quick. Thank you, Kent. I want to welcome everybody to the second debate of King Crocoduck and Ken Hovind, hosted by me, Steve McRae, host of the Great Debate Community. I want to thank both of you gentlemen on being here for part 2 of your debate that started 2 weeks ago. This debate should take about 90 minutes, and we'll be having more of a free-form discussion, plus having a Q&A that both of you guys have agreed upon from the live feeds when both of you are ready to have it. Hopefully allowing both of you to answer the same question, unless it is specifically directed to just one of you. Go ahead, King Crocoduck. Take a minute, refresh your memory on everybody's memory on who you are, and then we can have Kent do the same.
Hi, everybody. My name is King Crocoduck. I'm a YouTuber here. I've been debunking pseudoscience, mainly creationism, for the past 5 or so years. I am a researcher right now. My research is in computational biophysics. I got my bachelor's degree from the University of California, Santa Barbara. And yeah, my main reason I'm here is because I dispute Mr. Hovind's position that the universe is under 6,000 or so years old, whereas in reality it's closer to about 13.8 billion years old. So that's sort of why I'm here, and that's what I'm here to dispute.
Kent, do you want to do a quick opener for my listeners as well? And just FYI, we start getting a little bit of feedback from you, so when you're not talking, you may want to mute to see if we can eliminate that a little bit. But
this mic. Mute that when I'm not. Yeah, roll it. Okay, my turn to roll the way up.
Yeah, go ahead, Kent.
How do I know where? According to evolution, now complicated things happen automatically, so this microphone should not be a problem. Anyway, my name's Kent Hovind. I was a high school science and math teacher 15 years. I became an evangelist in about 1990, then full-time probably by 91. I defend the position that the Bible is literally true and scientifically accurate in every detail. The earth is about 6,000 years old. The whole universe was created in 6 days, and man brought death into the world, as opposed to the evolution theory, which says death brought man into the world, and death is the hero of the plot. I dispute that. I think that's ridiculous. I think there's absolutely no evidence of any animal ever producing any other kind of offspring. And I dispute the position that the fossil record could prove anything. There's no fossil record. There's a bunch of bones in the dirt. They don't prove anything. So my position is the evolution theory is not only stupid, it's dangerous. That was the foundation philosophy behind Adolf Hitler. Got to eliminate the inferiors. That's the foundation philosophy behind communism and socialism and Nazism and Marxism and a whole bunch of isms, and it should be called evolutionism versus creation. But they always say creationism. I disagree with that. And I hear different evolutionists, including King Crocoduck, whoever he is, talk about the accept evolution. I resent that. You believe in evolution. It is your religion. It's something you believe in. You don't accept it. You believe it. So that's my position. So go ahead.
Okay, thanks, Ken. Your mic is very low, just FYI. It does sound like you're at the bottom of a well at the moment. So if you can just maybe speak a little closer to it, it might take care of that problem, because it does sound really light. We can hear you, but it is at a distance. But we'll go ahead and you want to go ahead and continue from where we left off from the first part, from part 1. KC, you want to present first? Go ahead.
Sure, although I would just like to comment, even though we're not here to talk about evolutionary theory, this attempt to tie it to Nazism and the Soviet Union, I mean, really, you couldn't have chosen a worse example than the Soviet Union if you wanted to try to convince people that evolutionary theory convinces people to commit atrocities. I've spoken on this in the past, but the Soviet Union was notorious for its rejection of evolutionary theory. I mean, I take it that you've never heard of Trofim Lysenko and of Lysenkoism and of the millions of people who died because he believed that evolutionary theory was a reactionary justification for capitalism and the bourgeois domination of the proletariat. And I think that we're going to see a consistent theme of how there's this tendency on my opponent's behalf not really to engage with the substance and to not really, have much of a grasp of the substance. But we'll get to that when the time comes.
Okay, what exactly is the substance you're talking about, Crocoduck? What is the substance?
Of the issues that we'll discuss. We'll get to it, but first, could you please turn up your mic? I'm really having a hard time hearing you.
I am as well. Your mic is still really poor right now.
Well, we've been waiting for it to evolve. We're working on it. If I hold it closer, is that better, Steve?
That's better.
That's better?
Yeah, thanks, Kent.
Okay, I'll just hold it. I'll just hold it, Steve. Okay.
Yeah, much better.
Shall we carry on where we left off last time?
Kent, is that okay? Because there was 5 things you had both agreed upon during the past debate and prior to that and prior to this debate. Casey, do you want to pick one of those and kind of run with it?
Sure. Kent, you all right with that?
Or does Kent want to pick one?
Yeah, go ahead.
Okay, go ahead.
All right. Well, why don't we continue talking about our disagreements over the ambiguity of the different models of the age of the universe? First things first, though. I'm hearing.
Yeah,
I'm hearing a little bit of.
Can I mute you, Kent? I can do it on my end if you don't mind, while Casey's speaking, or do you want to do it on yours?
Yeah. Mute it on your end. That would work fine.
All right. So I am muting Kent just because I'm getting a feedback, and then when Casey, you're done, then I'll open back up. Okay?
Yeah. Well, I think that it can be shown compellingly through an analysis of the Friedmann equations, derived ultimately from the Hubble redshift and from general relativity, that the universe is in fact closer to about 13.8 billion years old than it is to 6,000 years old. You combine this with analyses of the cosmic microwave background radiation, whose existence was predicted decades before it was actually discovered. It was predicted as a consequence of the Big Bang Theory. And once you combine these two things, you also combine the accurate predictions of the distribution of the elements and of helium in particular. I think you have a pretty solid case for the Big Bang Theory being the correct model for how the universe went from its original state to the present state, and that it took 13.8 billion years to do it.
I would agree. There certainly seems to be a red shift when we look at the stars. I agree there seems to be a cosmic background radiation, and I agree that the elements are distributed irregularly through the solar system. The sun is very different than all of the planets as far as the amount of helium and the different elements, 92 basic elements plus the synthetic ones. I would agree with that. However, I don't think that has anything to do with proving the age of anything, nor does it offer any help for your evolution theory. As I always do when I talk about the topic of evolution, I point out there are 6 different levels or stages or meanings to this word. You're wanting to stay on level 1, which is cosmic evolution, the origin of time, space, matter, with the Big Bang. And I think that's a good place to start. That is what you have to have. You must have billions of years to make the rest of the theory look reasonable. If you want your frog to turn to a prince, you have to hide it in billions of years. A kiss won't do it. So I understand how desperate the evolutionists are to fight this particular battle to save the billions of years. However, the 3 things you mentioned, the Hubble redshift, the cosmic background radiation, and the distribution of elements, can just as easily be explained with a creation. And as I mentioned in our last discussion, 17 times in the Bible it says God stretched out the heavens. And so I don't see any problem at all with the universe being 6,000 years old and the stars, if we could measure that distance, and I don't think we can, but let's assume they are 13.72956 billion light years away. Okay, a light year is a distance. It's not a time. You don't seem capable of grasping that. It is a distance. It is not a time.
All right. Well, I'll respond first to this 6 levels of evolution thing. This is a non sequitur. This is clearly just an attempt to equivocate between the different types of sciences that go against my opponent's theological beliefs. In reality, you can find the word evolution throughout the entirety of science. There's not just 6 different kinds. I could show you the quantum mechanics textbook used by every physics undergraduate. It's called Introduction to Quantum Mechanics by Griffiths. There's a section in there called the evolution of the Schrodinger equation. Where does this fit into your 6 different types of evolution model? This is nonsense. This is a complete non sequitur. With regard to how creationism is able to explain these different things, the redshift, for example, it's simply not able to account for it. As I mentioned last time, the Hubble law, velocity, the recessional velocity of the distant galaxy being proportional to its redshift, the distances being proportional to the redshift. This is something that creationism is not capable of explaining. Saying that God stretched out the universe, what does this mean exactly? Is God like literally taking his hands and he's holding on to the universe and he's pulling on the edges, and what does this mean? What's this invocation of this weird mystical nonsense?
Let me answer that. Say one topic at a time.
Sure.
You have not ever, to my knowledge, in anything I've seen of yours, explained where matter came from, where space come from, or where time came from. You're concerned about these stars being a certain distance away, but I think you would agree that there is an enormous amount of mass in the universe. If you collected all the stars together and squeezed them into a ball, and all the planets that we've seen, there'd be an enormous amount of material. Where did that come from?
You wouldn't have material, actually. The temperature would be so high that it would all basically be radiation. It would just be pure energy. And this actually counts as evidence in favor of the Big Bang theory. Hello?
Yeah, time, space, matter, energy. Where did they come from?
That I don't.
You say something exploded with the Big Bang. What exploded?
That I don't have an answer to. That being said, though, that's irrelevant to the question of how old the universe actually is. Why the universe went from its initial state of a very hot, very small, and very dense state into the current cool and sparse state, we don't know yet. The question is how much time elapsed between these two states, and the answer is closer to 13.8 billion years than it is to 6,000.
And how do you know that, since you're 24 years old? How do you know there's 13.7 billion years? You're basing that on a distance to the stars?
22, not 24. But no, as I say, it's the Friedmann equations and the observation of the cosmic microwave background radiation.
Okay, explain these equations. People watching this debate are not impressed with all your use of huge words. I have a dictionary too. I could look up a bunch of big words. Explain it in layman language for the average listener. What does this equation tell us, and where did it come from, and what's the point?
Well, I haven't used any big words, Kent. Friedmann is 2 syllables. If you want me to start showing off, I'll turn on my webcam and start doing tensor calculus. This is just me trying to explain at the most basic level.
Okay, what is the Friedmann equation?
Yes, the Friedmann equation? The Friedmann equations, as I mentioned last time, are derived from Einstein's field equations in general relativity. And these tell us.
Still doesn't tell us what it is.
Sorry?
That still doesn't tell us what it is.
Well, I'll tell you if you let me.
Yes, please do.
Okay, so the Friedmann equation tells us how the space and how the universe changes based on the energy density of different parameters. How much mass is there, how much radiation is in the universe, what the relative concentrations of these things are, and how the universe can be expected to change in its shape and its size based on these parameters.
Okay, let's take that one bite at a time here now. Are you saying the universe changes its shape and behavior? What exactly is the shape of the universe, and what is beyond that shape?
Not its behavior so much. It's shape and whether it expands or contracts.
So what is beyond the edge of this expanding and contracting universe that you envision?
It's not clear as to whether there's an edge or not. There is an observational edge, and this lies at the cosmic horizon. But beyond that, there's nothing that we can say by definition, since that falls outside of the observable universe. I can only speak with confidence about what's the inside of the observable universe.
Okay, so this Friedmann equation tells us that if we have increased energy or increased mass, the shape of the universe changes. What on earth does that have to do with anything you're talking about here?
Well, when you take into account the distribution of different parameters, things like the amount of radiation, things like the amount of mass, and you get this, by the way, through an examination of the cosmic microwave background radiation. Once you have these parameters and you plug them into the equation, you can determine to what extent the universe has been expanding, and you're able to derive from this equation the age of the universe. If you know how quickly it's expanding, and you know how the distributions have been changing over time, then you can. It's very trivial to calculate how old the universe is. Very simplified.
Hang on, my 8-year-old grandson. My 8-year-old grandson is watching this. You're saying that some equation tells us that if we add more energy, the distribution of the material, the mass of the universe, changes. That's like, duh. If you drop a hand grenade in a room, the distribution of the material changes by adding energy. That's not what I said.
That's not what I said. I said that the different parameters, like things like the amount of radiation versus the amount of mass.
Okay. So if the amount of radiation changes by adding energy.
No, you don't add energy. You transfer between different types of energy. Right?
Okay, there's different types of energy. I agree.
Mm-hmm. Yeah, and if you convert between these different types, of energy, then if you do it to a sufficient extent, then the behavior of the universe is going to change. If you have more of this, the universe will expand. If you have more of that, the universe will contract, and so on. And the Friedmann equation tells us how exactly this works and how quickly these things are changing.
That's wonderful. If you add energy, things expand. You can add energy to a room and the air expands. I ask any weatherman; they understand that.
Not necessarily. No. You can. There are ways of adding energy and making things contract. If, for example, you were to have a lot of this energy, some of the pure energy coalesce into mass, it reaches the threshold energy to generate mass. And the mass has a gravitational pull, then things start to contract rather than expand. So you need to understand how these various, you have to understand how these various parameters affect the universe.
Let me see if I understand what you said. You're saying that energy can be turned into matter. Is that what, is that what I heard you say?
Yeah.
And where has this been demonstrated? Just energy. Let's take all the heat energy you want. What matter is that going to produce?
Are you familiar with the equation E equals mc squared?
I am indeed.
Okay, then it should be trivial as to how this happens. The process can go in both directions. You can turn mass into energy via nuclear.
Where has it been observed? Energy equals mass times the speed of light squared, which is what C stands for. That was Einstein's idea. And it may certainly be true, but you're saying that goes both ways? If it does, if the energy can be turned to mass, where has this ever been demonstrated? I think mass can be turned to energy all the time. You can burn up a wood pile and get a lot of heat out of it and reduce the mass to energy, but where can you get the energy to turn into mass? I'd like an example of that, please.
The wood pile thing is not an example of E equals mc squared. That's a chemical reaction. It's completely different.
But it's an example of mass being turned to energy. I would like you to show me or tell the audience, where has energy, just energy, ever been turned into material, mass, something solid?
Inside of particle accelerators, you can get masses very small masses, and the sum of those masses is, let's say, less than x. And you get these masses going very quickly. You add energy to them without actually, changing the mass. They still have a constant rest mass.
Think what you're saying.
Wait, hold on. I'm not finished. Okay. You take these two masses. Hold on. You take these two masses, and their total mass is less than x. And you speed them up and you crash them together, and then the end result is a mass that's greater than x. And you get this because of the energy that you've added to them as a result of them speeding up.
So the energy, your contention is you speed up two particles, crash them into each other. The result weighs more than the initial two particles. You started with two particles. What if you start with nothing, just energy?
If you start with just energy, in principle...
You can't have your two particles. You can't have your two particles. Just energy, turn it to mass. Where has this ever been done?
The Casimir effect is one good example.
Explain that to the average audience here.
Well, for the average audience. Well, you have a vacuum, and the vacuum has a ground state. That's the minimum amount of energy that any system can have. And this ground state, it basically has a certain amount of energy. And from this minimum amount of energy, you have particles and antiparticles popping in and out of existence. And this has been demonstrated with experiments like the Casimir effect, where you have the result of this vacuum energy causing two plates that are close enough to each other in order to be affected by this ground state, clamping shut together in accordance with the predictions. And without anybody actually adding any energy to it. It's a consequence of these virtual particles.
Okay, are these two plates that are clamping together, are they made of material? Are they visible?
Yes. So
you're starting with material. I would like you to have nothing to start with except energy.
There's nothing between them, that's the point. There's nothing between these plates. And this supposedly nothing causes something to happen. The plates end up clamping together.
Other than just a vacuum or a magnetic reaction or a...
yeah, there's just a vacuum there. Nothing else.
Okay, so we know that magnetism, which we cannot see, will cause two magnets to clamp together.
We're not talking about magnetism.
We know that a vacuum between two objects will cause them to clamp together. So you're saying there is something else.
The question is why. The vacuum has a certain ground state, as I said. And I don't remember the exact details of how the experiment goes, but as a result of these virtual particles, the plates do end up clamping together.
And do you think an example like that is enough to put your trust in that the whole universe, everything we see with trillions of tons of material, was created out of nothing in that manner?
When did I say that it was, Kent? When did I say that? Sorry?
Well, I was asking you, where did the material in the universe come from? And you give an example of this Friedmann equation and matter popping in and out of existence. Is that satisfy you that the whole universe came to being this way?
Kent, hold on. The way this conversation went was you asked me to demonstrate how old the universe was. I went into a conversation about the Friedmann equation. We started talking about the composition of the universe via things like energy and mass. And then we got to Einstein's equation, and you asked for an example of how energy can be turned into mass, which is what I just gave. At no point was what I just told you a premise for an argument of the universe coming from nothing. There are some models that do suggest that this may be the case, but nobody's saying that this is something that's as firmly confirmed as the Big Bang theory. So let's not equivocate here, Kent. Let's stay on topic.
I'm not equivocating. I'm trying to draw it out of you that you have an intense religion, not a science. Nobody's ever seen any of the universe pop into or out of existence, or without incredible energy input to create this energy vacuum, or whatever you called it, that caused the two plates to clamp together. This was all done in some machine made by some man, I'm assuming, with some intelligence. This doesn't just happen by itself. So
okay, but that's not the point. Kent, you're missing the point. This is what I mean by equivocating. Hold on, you're equivocating between what I'm trying to demonstrate and what you want me to try to demonstrate. What I'm demonstrating is that energy can be turned into mass. That's what you asked me to demonstrate. Now you're saying, aha, but you haven't demonstrated that the universe can't come from nothing. Okay, I mean, well, if you want to do that, by all means, try it. But like, you're arguing with yourself now.
So you're saying that an experiment was done in obviously some man-made machine using a lot of energy, a particle accelerator, which takes an enormous amount of energy.
Well, in this case, no. For the Casimir effect, no. You don't need a particle accelerator for that.
Was there any kind of design to this particle accelerator, or did it come by chance? Somebody designed it.
Well, clearly, yeah.
Okay, good. So if particles can come in and out of existence, let's assume that's true. I think I'd have to watch that to have mass change to, energy change to mass. I think we see mass change to energy all the time, and we see all the stars are burning up. Our sun is burning up. It's changing mass to energy. But is there any place where the sun's energy can be turned back to mass? Material.
That's not. It could be, but that's not part of the process. Nuclear fusion just says that. Well, let me think about that for a second. It could be the case that you have two lighter elements that are fusing into something that is less than the sum of their masses. In which case, some of that mass is lost to energy. That's basically what causes nuclear fusion. Okay, but you have to understand that the equal sign points in both directions. Now, whether or not this happens in the sun, I don't remember at the moment. But I do know that, at least in the case of the Casimir effect and other similar experiments testing quantum vacuum fluctuations, this is all part of quantum field theory, that it is possible for energy to turn into mass. Sorry?
It's a theory. I'm asking, where has this been observed? Einstein
I just told you the Casimir. The Casimir effect.
Well, could it be the equation, the equal sign, should not go both directions? It's only observed going one direction.
Come on, Kent. An equal sign is commutative.
Oh, believe me, I understand. I taught math for years. I think I can handle an equal sign. But I'm asking you, I know mass can be turned to energy. But you would like the audience to believe, I assume you would like the whole world to believe, this evolution theory, which really would have everything come into existence from nothing. Ultimately, you have to start with nothing and have some kind of material. Where's the material and the energy? You got either one or the other. You got to start with one or the other, or both. Where did it come from?
I told you already, we don't know where it came from, but that's not what the Big Bang tells us. The Big Bang tells us how the universe came from its initial very hot and very dense state, where there was a lot of energy, into the current very sparse and very cool state.
Okay, so would I be safe to say that you do not know where the initial energy came from to heat up this speck or whatever?
Yes.
You're saying you don't know where the energy came from. Okay.
Yeah, nobody knows.
Nobody knows. Okay. The energy, we have a thunderstorm here. We may lose power. I don't know about that, but so this energy somehow turned into material. And is it your position that all the 92 elements that we have, the naturally occurring elements, gold, silver, platinum, came from this energy spot?
Well, not right away. What happened was the universe expanded, and what's called the threshold energy is reached. And this is the energy that corresponds to the ability of a certain mass to condense from the energy. And what you initially have is this enormous, very hot and very dense soup of protons and neutrons and other fundamental particles, quarks, probably not in isolation though. And what eventually happens is gravity pulls many of these elements together. It becomes very dense, very hot, and they begin to fuse. And through the fusion process, over time, you have the development of more and more elements across the periodic table. You first start out. Hold on. Could somebody mute Kent? I'm getting some feedback.
And if I may, I'm getting some positive and negative feedback so far from the different feeds. I think people wanting to kind of redirect it back to the original question and dealing with the age of the Earth rather than the origin, the ontological aspects of the universe. I think the critical question that was initially asked was dealing strictly with the age question, not so much to where did everything originally came from. That is an entirely different question. So let me just throw that out there. If we kind of redirect back onto that, because I think that's what both live chats are kind of asking me to do.
Okay, I can understand clearly why they would not want to get into the question of where did the initial energy and mass came from, because they don't have an answer. But yet they want all of this to be taught at taxpayer expense and forced on all the kids. This is something should be taught in a private school where the kids want to come learn evolution. It should not be a taxpayer expense where everybody has to pay and learn this stuff.
This actually was more. If I make it, this was actually more from your feed than it was from mine. So the people watching your channel was asking me multiple times to redirect. So it wasn't just unilateral to mine. Okay.
Yeah.
So
they
really
can
quickly,
ask anything they want, but I'm still wanting to know where the mass and energy came from. I don't think we've got an answer here. If you want to start with something, you haven't really got a good theory. We don't have an answer to that. You have a religion. Admit it.
No, Kent. You're not understanding. The Big Bang Theory doesn't tell us where the initial mass and energy came from. We don't have that answer.
I know it doesn't.
Hang on, Kent. What we do have, and what is being taught in the public school, is that you initially have a universe that is in a state that is very hot and very dense. It doesn't say anything about how this very hot, dense state came to be. Maybe a god put it there. Maybe it came there spontaneously through processes we don't know yet. It doesn't matter. It's irrelevant. The question is, what happened to this? How did it happen? And to what extent? And how did it end up to the way it is today? We have this initial very hot, very dense state. It expands, and here we are today, 13.8 billion years later. This is what the Big Bang addresses.
This is why it's precisely, as I've said for years, it's a religion, something people believe in. This is not observed ever. All we observe is this equation going one way, mass turning to energy, but not energy turning to mass without adding a bunch of more energy to make it happen.
I just gave you an example.
How did you accelerate these particles? Where'd this energy come from? And where'd the particles come from?
No, the Casimir mechanism I told you. The Casimir plates.
Well, explain that to the average audience. Who's Casimir, besides a sweater?
Kent, I just spent like several minutes telling you about this experiment with the plates and the Casimir effect.
So you're saying mass comes into and out of existence in a particle accelerator. Now, how big is this amount of mass that they're producing?
It's not a particle accelerator. The Casimir effect happens with two plates. There's no particle accelerator involved in this case.
Right. So, and I mentioned there are several forces that will cause two plates to snap together. Gravity will do it, vacuum will do it, so Casimir can do it, okay? Put a sweater in
the vacuum, that's exactly it. The vacuum is what I'm talking about. Again, you have the ground state of vacuum. Okay, so what are we arguing about? We seem to agree that the vacuum energy spontaneously produces particles and antiparticles.
No, I didn't say that. I said there is a thing called vacuum energy.
You just said the vacuum energy was responsible. What do you think the vacuum energy is?
Okay, now, if the vacuum is between these two plates, is there something on the other side of these two plates pushing? Like you pump the air out of a cylinder, you can, the vacuum is actually the pressure on the outside, like your tire pressure.
To my knowledge,
increase the pressure on one side.
To my knowledge, these plates were left inside of a vacuum to avoid that.
Okay, well, that's wonderful. So there is a vacuum energy, and that is enough to cause you to believe that the universe that we observe came from a very hot, very dense ball of something. And so you want to start with something. So I would believe in the beginning God, and you would believe in the beginning a speck or something, a hot speck. You start with a belief, though.
What the Casimir effect is demonstrating, what this vacuum energy is supposed to demonstrate, is what you're suggesting cannot be demonstrated. That mass can come from energy.
You started with a very hot mass, even though it was tiny. Did this initial mass that you're talking about?
No. It was not mass. It was not mass. It was just energy.
What was it? It was energy. Did this initial where was this initial speck of energy at? Where did the space and the time come from for this to exist? Did it exist in time or space?
Ontologically, I can't really answer that. I don't have an answer to that, but I can tell you that when the Big Bang started, this energy occupied the entire universe, however small that was at the time.
And the universe may have an edge someplace.
Perhaps, we don't know.
If the universe doesn't have an edge, so this energy was spread out everywhere. If it did have an edge, the energy was contained somehow. And what's on the other side of this boundary, our visible boundary, or
well, here's the problem. You're using this sort of intuitive philosophical deduction for a system where these kind of syllogistic arguments really don't apply. I mean, let's take something as basic as Newtonian mechanics, which says that everything has the same acceleration inside of the same gravitational field. You push an elephant off of the Empire State Building, you push a laptop off the Empire State Building. They both still have the same acceleration. That's not intuitive at all. But
depending on wind friction, right?
Yeah. Well, no. We're talking about acceleration. We're not talking about velocity.
But the feather and the elephant will fall differently only because of air friction. If it were in a vacuum, they'd fall the same speed. I understand.
Yeah, but I'm not talking about speed. I'm talking about acceleration. But the point is, here's something that's unintuitive even at the classical scale. Now we move on to something like relativity and quantum physics, dealing with high energy and small systems, and intuition flies out the window, and you can only start to use equations and math in order to grasp these things. And they're very successful at predicting future data. You and I would not be able to talk right now if not for the success of some of these theories. So here we are trying to understand the smallest, highest energy system imaginable. And you're using this kind of syllogistic reasoning that fails even at the classical level. It's not going to end well.
I'm trying to get it clear for the listening audience. I doubt you're going to get it. What is currently all of the galaxies, all of the stars, all of the planets, my old Chevy van, everything existed in a state of energy in one little speck.
Mm-hmm.
What do you call it? How big was this energy spot?
It's not clear. Just really small. I would have to look it up. I can't tell you exactly. Maybe it was 1 Planck length. Maybe.
Okay, so my old Chevy van and the whole universe and all the planets and all the stars existed in a extremely small spot of energy. Do you really believe this, Crocoduck? I mean, are you serious? You really believe this?
What's the matter, Mr. Hovind? Does it tickle your intuition?
It tickles my funny bone. I think it is so stupid, like beyond capital S stupid. I am amazed an intelligent person would believe such a thing. You have to go to school for years to believe something that dumb.
We haven't even touched upon quantum mechanics, Mr. Hovind. Do you believe that it's possible for an object to occupy multiple mutually contradictory positions at once?
Ooh, I guess you'd have to explain what you mean by that. Give me an example. Can something be in two positions at the same time, or two things be in the same spot? No, that's I think they're mutually exclusive. I think space is I don't know what the word they would use for it. No, I cannot be in the same spot as another person occupying the same space. Can you? Can
I? Me personally, no. My de Broglie wavelength is too short. But do you believe that it's possible for an electron to hit a barrier, and a barrier for which the electron doesn't have enough energy to go over the barrier or to punch through it, and yet the electron appears on the other side of the barrier? Do you believe that's possible?
Well, no, those are interesting experiments. I don't know that. I don't think anybody knows for sure what is causing that kind of thing. But if electrons are whizzing around, nucleus very rapidly, they don't seem to ever be losing any energy. Has this been going on for 13.7 billion years? Where did this electron get excited? Who's buying the gas for this electron to move around?
Wait, are you saying that electrons don't lose energy as they're in their orbitals?
Well, let's take a carbon atom, which has X number of electrons whizzing around it, around the nucleus. Do those electrons ever lose their energy over time?
Yeah.
Does it change to something else spontaneously?
Yeah, their energy can change. You have, let's say you have an electron occupying the fourth shell of the electron, or of the carbon atom. it can jump down to the third shell or the second shell or the first shell, and frequently does, and it releases a photon in the process.
Do they ever get tired and just fall off and lay there in a pile? You know, do we ever get a pile of these electrons anywhere that just totally ran out of gas?
What are you saying? I don't understand the question.
Well, it seems like all the electrons whizzing around all the who knows how many molecules there are in the universe, that would be incalculable, I think. All of these, first place, just the atom is really complex with the neutron and the proton and the space between them, as you mentioned, the orbitals, the SPD orbitals. Okay, where did this design come from? How did it get moving in the first place? And obviously, the proton and neutron have some kind of mass. Electron has a little bit of mass. You're not answering where did this matter come from. To just say it came from energy is not answering the question. You're ducking it. And you not only believe this, you not only believe this, you want everybody to pay for this religion to be taught. This is ridiculous.
It's not a religion. We've seen the process happen.
It is a religion. You believe in it.
You have a certain amount of energy, and the energy can condense into mass. I hope that by now we've established this with the Casimir effect.
Oh, let's assume it's true. It can happen in a particle accelerator or in an accelerator. Okay, let's assume that's true. You believe, and you
not
believe.
A particle accelerator. It's just two plates.
Okay, but the Casimir effect, I know. So that's enough to convince you that everybody should be required to learn that the whole universe came from this effect for no reason.
When did I say that? Kent, why do you keep on
an obvious implication is that
no, it's not.
The universe came... Do you believe in the Big Bang Theory?
Yes.
You do. Why? What's the evidence? Just the starlight, the red shift? Is that your primary evidence? Or you mentioned a couple other things. I wrote them down quickly here.
I mentioned the cosmic microwave background radiation and the distribution.
Cosmic background radiation, which all of those could just as easily be explained by a creator doing it. But yet we all have to pay for your religion to be taught in the schools. This isn't fair.
It's not a religion. It's not a religion because the model... Okay. Saying that over and over doesn't change the facts, Kent. You can say it's a religion, it's a religion.
And you denying it doesn't change the fact either, okay?
I'm trying to show you the evidence, and you just keep on saying it's a religion, it's a religion. I mean, I could play this game too. Anybody can show me evidence, and I'll stick my fingers in my ears and say, la, 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 it's a religion.
I looked at your evidence and said this can just as easily, and that's enough to convince you. Cosmos magazine, I think it was just yesterday, I downloaded this. A new theory proposes that faster than light particles, known as tachyons, could answer a lot of questions about the universe, writes Robin Arian Rod. Here are 6 big questions.
Where was this published?
This is Cosmos yesterday, okay? Okay. Here are 6 questions about our universe that current physics can't answer. Number 1, what is dark energy, the mysterious energy that appears to be accelerating the expansion of the universe? Number 2, what is dark matter? Number 3, what caused inflation? Number 4, for that matter, what caused the Big Bang? They don't know these things as of yesterday, but you do.
I don't claim to know that. And first of all, Kent, why are you using a popularized science website to try to establish what should be established in the literature? Why aren't you consulting with actual scientific sources? Why? I mean,
well, show me where this. You're saying this equation, mass to energy, is an equal sign between. I agree, that was Einstein's equation. But what we observe is the mass turning to energy way more than the energy turning to mass. And you think all the mass came from some energy. So you think it was a one-way equation at one time. Your Big Bang has to start with an arrow, not an equal sign, because you had nothing but energy. And you didn't tell me where this energy came from, where space came from, or where time came from.
I don't need to. The Big Bang Theory doesn't answer these questions.
Well, then it's a religion. You believe it happened. I don't want to pay for it anymore. Get it. Go teach it. Go start a private school and teach it to those who want to come learn it.
No, Ken, you're missing the point. What is the Big Bang Theory?
I'm right on the point. Believe me, I'm on the point.
No, what does the theory tell us? What is the point of the theory? What is the model trying to describe to us?
Well, if we observe that we have a lot of stars out there, they all appear to be burning up some kind of fuel, generally hydrogen, helium, okay? They all appear to be producing an enormous amount of light that we can see from a long ways away. But they're all burning up their fuel. I think we don't observe this energy they're producing changing back to matter any place.
Hold on.
The sunlight.
Kent, what does the Big Bang Theory say? That was my question.
What now?
What does the Big Bang model show? What is it trying to demonstrate? What's the model describing?
the Big Bang Theory says all the matter and energy in the universe was in one tiny dot, which is what you said. I'm asking, I'd like to go a little before that, before I want all the tax dollars to go to pay to have these kids taught that at taxpayer expense and at gunpoint. Ultimately, if you don't pay your taxes, they take away your house. So ultimately, it's forced on everybody to teach that this is true. And you can't even give me square one. Where did the energy come from? Where did the space come from?
Kent, hold on. I can tell you a lot of things about my computer, about how it works, about how the various processes are in it, without ever even knowing myself where the computer was made or who built it. This is nonsense. You can't make something without its origin. Sorry, hello?
Right. You believe someone did build the computer, though. You don't have to meet the guy or girl. You believe they did it, right? Someone did build your computer?
Sure.
Okay.
That's beside the point.
But yet you look at a cell, and one cell, get one cell out of your skin and look at it under the microscope, which is way more complicated than any computer you could possibly have. One single cell, more complex than all the computers in the world combined. You think that happened by chance from this explosion of a bunch of energy exploding?
Let's say for the sake of argument that I couldn't tell you anything about the origins of a cell. Does that mean that I can't tell you how the cell behaves and how it changes over time?
No, that's correct. Now, I agree. Cells change. They behave in certain ways. I taught biology. I think I could hold my own on that one. Go ahead.
So if I don't know what the origin of the universe is, that doesn't mean that I can't tell you how it's been changing over time.
Oh, I agree. The universe is changing. I agree. The stars are burning out. The stars seem to be moving away from us. I would agree with you on that. I think I said so.
No, not just that. I can tell you about its lifetime after the mass and the energy and the space and the time was already there. I can't tell you what happened prior to the expansion. I don't know that. But that doesn't affect what I can tell you about what happened after it. And you are trying really hard to equivocate between these two. It's kind of sad to watch.
I'm trying to get you to admit to the listening audience you don't know where the energy came from. You don't know where the space came from.
I told you like 3 times.
Well, then wonderful. So my point is, this is something you believe happened.
What do I believe happened?
Which is, you believe energy, which was able to turn into mass, all of the stars, all of the planets, my van, everything was squeezed into a dot of energy, really hot, really tiny energy.
Yes.
You believe this. I believe that you believe that. I do. I don't think it's intelligent. I think it's silly. I think it's flat stupid to believe such a thing. But if you want to believe it, that's fine. But that's not science.
Why is it not
Nobody
science?
observes this.
Kent,
We don't observe spots of energy turning into vans.
Kent, you're equivocating again. What I don't know, let me finish, Kent. What I don't know is how that energy initially got there. I don't know how the space and the time initially got there. I don't even know if it means anything to say that it initially got there. What I do know, based on things like the cosmic microwave background radiation, based on the proportionality of the recessional velocities to the distances of the galaxies, based on the distribution of the elements, what I can tell you from all of this is that based on the scientific evidence available, the best model that tells us for how the universe came to be in the way that it is that it expanded from this initial very small, very dense, very hot state over the course of 13.8 billion years. That is not the same thing as saying that it all came from nothing. You keep on missing the point, and you keep on calling it a religion.
No, I'm right on point. Believe me. Could you be extrapolating back too far? We observe, and in the last, I don't know when did they first start measuring the red shift? In the last 100 years, I think. I don't know. It doesn't matter. Okay, Hubble and these guys, in the last 80 years, okay, they have been observing the stars are producing a red shift. Yay. This is interpreted as the stars are moving away, like the Doppler effect. Okay, I agree, that's probably true. The stars are probably moving away from us. So we've watched the stars move away from us for 80 years, and you want to extrapolate that back 13.7 billion years. Could they have started 80 years ago moving away? Could they have started 6,000 years ago moving away? Why do you want to go back to?
That's a very good question, Kent. That's a very good question, and it's a very good question, and it's the first good question I've heard from you today. The answer is the cosmic microwave background radiation. It was predicted. Let me check. It was 1948, I believe. Yes, 1948, by Ralph Alpher and Robert Herman, a couple of physicists, and they said that if the universe was indeed in this very hot and very dense and very small state, that all of the mass had to basically be compressed into this really small kind of dot. and that because it would have been so hot, all of this mass would have just been pure energy at that point. And that following the expansion of the universe, the expansion would have caused a cooling of the universe. And there would be some trace of this left behind in the form of a background radiation. And they were able to predict, based on how fast the universe was expanding, based on the Hubble constant, and based on their knowledge of the relationship between temperature and changes in volume, that the background radiation should be approximately 5 Kelvin, and that it should be visible everywhere. Then in 1960, they detected it. Not the same guys. It was Penzias and Wilson who found the background radiation that was predicted 20 or so years earlier, 10, 20 years earlier.
Sure. Oh, it's wonderful. Now, is there anything else that could be causing this cosmic background radiation? I think it's 3.7 Kelvin is what a number I heard, but it doesn't matter. We're talking real chilly, okay? On the Fahrenheit scale, about minus 452, okay, whatever it is, 450.
Yeah, it is indeed about 2.7 Kelvin. 5 Kelvin is a pretty good prediction.
It doesn't matter. Now, is there anything else that could be causing this, or is that enough to have you tell everybody that they must believe this is evidence that it all was in one dot and exploded? Is there anything else that could cause this cosmic background radiation?
There could be, but this is beside the point. Well, we'll talk about alternatives in a second. The point, as I mentioned last time, we judge a theory's strength by its capability to predict future data. Nobody had even conceived of the possibility of a cosmic microwave background radiation prior to the Big Bang and prior to this calculation. The fact that this calculation succeeded, and the fact that they were able to accurately predict the existence and the temperature and even other features of this background radiation, its isotropy, its homogeneity, they predicted all of this prior to actually measuring it. This is very strong evidence in favor of the model. It shows that we can actually make accurate predictions about future data using this model of the Big Bang theory.
Okay, well, let me make a prediction then. I have a model that says God created all the plants and animals to bring forth after their kind.
What does this have to do?
If you have children,
why are you changing the subject? I thought you said one subject at a time.
I have a model that makes predictions. My model says everything will bring forth after its kind. I predict dogs will always produce dogs, and no matter how many, and you, if you have children, they will grow up to be human, and they will be human, and their children will be human, and their children's children will be human. I think our model is predicting things just fine. How does this cosmic background radiation negate the idea that in the beginning God created the heaven and the earth, and God stretched out the universe, like he said 17 times, he stretched out the stars? How does your model prove that to be not true? Could that still cause the cosmic background radiation?
There are some Christians who believe, and I'm not saying necessarily that I agree, but I'm saying that there are some Christians who look at the science and they say, okay, it does appear that the universe is 13.8 billion years old. It does appear that the universe began in this very small, very hot, and very dense state. So they say, okay, God stretched out the universe, and that was the Big Bang, and he's continuing to stretch it out. And as the universe was stretched out, this really hot and dense material, over the course of about 160,000 years, 380,000 years, it cooled down sufficiently in order to, it became sufficiently sparse for light to be able to freely move across the universe and bring us this image of this background radiation. And God stretched out this universe, and things began to cool, and things began to coalesce under the influence of gravity. You know, in principle, a person can believe this. But if you want to believe that in the beginning, the universe was created in 6 days over the course of 6,000 years, and that there was never this really hot, dense state that I'm telling you about, then you're simply wrong. The existence of the cosmic microwave background radiation and the successful prediction of its existence and temperature does indeed negate this latter model.
So the fact that we have a cosmic background radiation, which is obviously something above absolute zero, so again, you have energy someplace coming from somewhere. The existence of this cosmic background radiation of 2.7 degrees Kelvin, or negative 452, whatever it is, Fahrenheit, this proves that God did not create the universe in 6 days, 6,000 years ago. That's your
Correct.
contention. And when Jesus said the creation of Adam was the beginning, he was lying. So that's your contention. That
There are plenty of Christians who interpret that allegorically, Kent. In fact, most of them do.
Okay, I don't. Observing this cosmic background radiation for the last 40 years or whatever it's been seen, and you're offering one explanation for how it came to be. I agree the universe is probably expanding. I think there's a different reason for it. Now, as far as the universe expanding and cooling, I would go back to you don't have a coherent theory explaining where the mass, energy, and space and time came from, and you admitted that. And I thank you for that. I wish all
That's not what
evolutionists
the Big Bang Theory tells us, Kent. That's not the point. The point is to tell us, again, for like the 50th time, how did we get from this hot, dense state to the sparse and cool state today? How long did it take? And what features were seen in between?
So for 80 years, we've observed a red shift, and for 60 years, we've observed a cosmic background radiation. And that's enough to get you to extrapolate back 13.7 billion years with a B and tell us that some tiny dot exploded. You really believe this?
Well, Ken, asking me, this sounds like an argument from personal incredulity. The model has successfully predicted these lines of evidence. If you don't like it, tough. I don't care how badly it conflicts with your personal intuitions.
It is incredible. It is incredible to me that an intelligent person could believe such a thing, but you're welcome to believe that.
Guys, now, we're gonna get this back. Ken, we're gonna get this back a little bit. Both live feeds are kind of saying we've diverged from the original topic and kind of migrated into other areas. You guys had both agreed upon a Q&A. Do you think this is a decent time to start the Q&A?
Sure.
Okay, awesome. I am watching both live chats. I'm looking yours, and I'm asking for people in your live chat, Kent, for questions, as well as my own on my own channel. So as soon as they start popping in, we can definitely start asking them. Do you want to ask each other a question first with each other? I know you kind of been going back and forth, but is there specifically a question you want each other to ask that has not been brought up yet?
I've asked plenty. Go ahead, Croc.
Okay. How are we able to see light from, say, 10 billion light years away?
I would like to know how you measured that distance. Just by luminosity? Is that one star is brighter than another, and so therefore you assume a distance based on that? 10 billion light years is a really long ways to measure.
Okay, so what? The principle still holds. We have standard candles. You look at the magnitude of a type 1a supernova. The magnitude is always going to be the same. All you have to do now is just compare the apparent brightness at peak with the absolute brightness. And you can plug it into the distance modulus equation. I talked about this in one of my videos to you, and you can end up with a distance. And the distance, of course, when you compare it to what the Hubble equation says, those two distances cross-confirm each other. So that's just one example.
Okay, so if the star is indeed 10 billion light years away, which I still think we should, they probably are. Okay, I'm not saying they're not. I just like to point out to the audience, using normal methods of measuring things like trigonometry or parallax, you're not going to go beyond 100 light years, not 10 billion light years. And there's a big difference.
Well, not in the visible range, certainly, but sure. there are methods with parallax where you use radio waves instead of visible light. And what you effectively create is a telescope the size of the Earth. And you can, as a result, go something, I forget what the latest, but I think it was something like 200,000 light years with parallax once you start doing it in the radio waves. But yeah, when you get to billions of light years, we're not ready to do that with parallax yet. We don't have good enough equipment.
Correct. I would agree. So I answered the question in the last discussion or debate we had. How do you see these great distances? Well, my Bible tells me 17 different times that God created the earth first and then the stars, and he stretched them out. So he could have done that yesterday to stretch them out to a certain distance and still be able to see them. Adam and Eve would see the taillights of the stars as they're receding, and they could be billions of light years away and still be 6,000 years old. So that's my answer to your question.
I think what you've just said betrays an astonishing misunderstanding of how astronomical observations are made. Let's say, for the sake of argument, that the sun disappeared right now. How long would it take for us to realize that this had happened?
I'd have to check and see, are we at apogee or perigee, but around 8 minutes. I mean, you could find the exact distances at 93 million or 92.9 million, or you go in an oval, but whether it's apogee or perigee would alter a little bit, but approximately 8 minutes it would take, okay?
Okay. Now let's say instead of disappearing, the sun, just permanently disappearing, the sun disappeared and reappeared 18 light minutes away. What would happen over the course of the next, how long?
We would all
just give me a
freeze
sequence of events of what we see.
Yeah, we would all freeze to death.
Well, let's suppose for the sake of argument that the Earth's physics don't change. Some other mass gets placed in there, and we have our own source of heat trapped here or whatever. This is just an idealized thought experiment.
Okay.
The sun disappears, and it reappears 18 light minutes away. What happens?
The sun is now 8 light minutes away. You're saying it disappears 18. And it reappears 18 light minutes away.
Uh-huh.
I guess I'd have to say it moved.
Okay, but what happens is for the first 8 minutes, let's say that over the course of these 8 minutes, the sun has already, it's just vanished from its initial position 8 light minutes away, and it reappeared 18 light minutes away immediately. For the first,
okay, it would take 18 minutes for that light to get here.
Okay, but in the meantime, for the first 8 minutes, we are seeing the sun at a distance of 8 light minutes away.
True, it would take us 8 minutes to know that the sun disappeared. I agree.
Right. And then after waiting another 10 minutes, we would start to see the sun again, because at that point, the light from 18 light minutes would come and reach us. Yeah,
okay.
8 plus 10 is 18?
Sure.
So now apply similar reasoning to the galaxies. Adam and Eve supposedly saw the galaxies, and as we established last time, they had to be between 2 light days away and 6,000 light years away in their initial positions in order for them to have been seen throughout history.
We did not establish that. You said that. I don't know how God did it all. We'll have to wait and see on that one. But I think the problems that we have with the creation model, as you call it, and I would agree, are so insignificant compared to the problems with your crazy Big Bang model that nothing exploded and made everything.
Even if that were true, this would just be a tu quoque, but that's beside the point. Let's apply the same reasoning to the galaxies. We have, supposedly Adam and Eve saw these galaxies closer, and then the galaxies were suddenly pulled away. God stretches the universe. The light that we would be seeing of these galaxies 13.8 billion light years away, or 10 billion light years away, say, would not be reaching us until 10 billion years after they reach that position.
Okay, are you assuming then that the speed of light is the absolute standard and speed limit, and nothing ever goes faster than the speed of light?
What do you mean?
Can anything ever go faster than the speed of light?
Nothing with no. Well, as far as we know, there's nothing but the rest mass is able to go faster than the speed of light.
So, in my seminar, I quote experiments from Princeton, Harvard, Yale, etc., about them speeding light up to faster than the speed of light. Princeton, I'd call it up here in a second. Here, they've speeded light up to 300 times the speed of light. What did they do there? What does that mean?
Well, let me see here. Are you referring to the experiment by Wang, Kuzmich, and Gagarin?
Well, I got 7,000 slides in PowerPoint. I'm trying to find it here. So watch my video number 7, Q&A. I cover this with all, here we go. Stellar distances. They just in the last 10 years were able to increase stellar distances up to 482,000 million miles, which is 82,000 light years. They just were able to increase it. This is from, let's see, Jet Propulsion Laboratory, July 1st, 2004. So they now have been able to finally measure up to 82,000 light years. And you're asking me a question about a star 10 billion light years away. Congress doesn't know there's a difference between 82,000 and 10 billion, but there is a difference, okay?
Okay. Let me address the first one that you just referenced. That one wasn't, I was correct, that one is Wang, Kuzmich, and Gagarin's experiment. What actually ended up happening was they didn't change the speed of light. What they changed was the group velocity, which is different from the actual speed of light. There are 3 different velocities associated with light. There's the group velocity, which tells us how quickly its shape is changing. There's the phase velocity, which tells us how the average speed, not the actual speed of light, but the average speed as it goes from molecule to molecule, changes. And you see this when it goes through a medium like water or through glass.
Sure.
The light itself isn't changing speed as it goes between these atoms. It's just that these atoms are knocking the light around. That's the phase velocity. And then there's the front velocity, which is the speed that it takes from light to reach point A to point B. The front velocity never changes. But the group velocity, which is what this group did end up changing, that you can adjust that, and you can also change the phase velocity. In every example that you ever give me, I guarantee you that you are only going to ever show me a change in phase velocity or group velocity. You're not going to show me a change in front velocity, which is the kind of velocity we're talking about when we're talking about changes in the speed of light.
Sure. So my question was, your contention is the speed of light is the absolute. God is limited by this speed of light. He could not create stars and the light showing. If the creation model is true, God made Adam and Eve full grown, mature, and apples are already on the tree. I guess I find it a very minor problem, a minor leap of faith, a little tiny jump of faith to say, okay, God could make the light and the stars simultaneously. God is not, my God at least, is not limited by the speed of light. That sure beats the idea that all this light and energy and stars were in a tiny dot that was really hot, that you believe.
No, it doesn't, because what you're effectively saying is that, in principle, the universe could have been made 5 minutes ago.
I suppose theoretically it could have been, including our minds with their memories implanted. I'm not saying it is. I don't believe that, but in theory it could be.
So what fundamentally is the difference? God creates a universe that appears to be billions of years old, even though it's thousands. Well, maybe the evil Cartesian demon, maybe you've heard of Descartes' Cartesian demon, maybe he created the universe 5 minutes ago and is deceiving us with our false memories, and he's implanting ideas into our heads, and we've only been having this argument for 5 minutes instead of however long we've been doing this.
That's all. I understand that very well, and that's all. If I suppose, and if somebody believes that, and there probably are people who believe that, they're welcome to. But that is, again, their belief. That's their religion, and we shouldn't all be forced to pay for that in the schools for all the kids to learn. And you want everybody forced to learn your religion, and it is a religion.
It's not a religion, Kent, because I don't have to postulate that the laws of physics are an illusion, as you're suggesting God did.
All right, let's move on to the next question if we can. Let's move on to the next question.
Okay.
I trying to keep the questions relating to physics. Obviously, you guys are discussing cosmology and those related questions, but we're having a lot of different types of questions out there. So I'm going to ask actually this particular question because it is physics related, although not cosmic, and I guess it is directed to Kent. Tyler Durden wants to know how much heat would have the carving of the Grand Canyon during a 40-day flood would have produced? How much heat?
How much heat would the carving of the Grand Canyon produce? Well, the flood was actually, Noah was in the ark for over a year. The earth was inundated, plus or minus several months. Noah, and most of the water came from inside the earth. With the creation model that I hold to, and most Christians do, I believe, that the Bible teaches that there was a canopy of water or ice above the atmosphere. So you would have multiple things happening simultaneously. When this canopy collapsed and it began to rain for 40 days and the fountains of the deep broke open, you would have energy released in the water coming up. You would also have the canopy collapsing, and you'd also have the atmosphere expanding, which is going to absorb heat. So I don't know all the mechanics of it. I know expansion of the atmosphere would absorb any heat, the latent heat of condensation from rain for 40 days. As far as the carving of the canyon, that probably happened. I think Grand Canyon probably came 100 years after Noah's flood, when Grand Lake is the name they give to it, even though it doesn't exist. Where the beach line is clear across, Idaho and Utah and Colorado. There was obviously a great big lake. If you dam up Grand Canyon and follow the elevation lines around, it makes a monster lake, 2 lakes actually, that would form. They probably overtopped the dam and carved the canyon maybe 100 years after the flood. We don't know. Nobody would have been there. So as far as how much heat was produced, I don't know how you calculate that.
Casey, do you want to try that?
Well, you could calculate that through the frictional forces and the amount that gets released as a result of heat. But Kent, having taught science, would know all about that. What I want to focus on is this even more fundamental problem with what kind of traces would have been left behind had there actually been a flood. I'm not really that knowledgeable on geology, but I do know that when you have a depositional environment that involves a flood, it does leave behind a layer called graded bedding. What this essentially means is that you have larger particles at the bottom and smaller particles at the top. And they're not sorted in order of any particular composition. It's not like, okay, you have chalk on this level and iron on this level and silicates. No. It's just the size of the particles. It's biggest at the bottom, smallest at the top. And if you have this global flood taking place, then you should see at the Grand Canyon, and indeed everywhere in the world, this one layer of graded bedding. But we don't see that. We don't find this layer anywhere. And that's how we know that this global flood never took place. But of course, then again, maybe God could have made the flood happen and changed the laws of physics to make it not look that way. I don't know.
All right, this next question comes from Joe.
I'd like to respond to that one.
And then I'll get to Joe's question. Yes, please.
I agree you don't know. I'm glad you said that. It is not correct that the larger go to the bottom and smaller go to the top. They're sorted by density as well. You could have small particles of lead that would go to the bottom of large particles of styrofoam. So density plays into this. Plus, you get a flood lasting months. The tide being up and down would cause a vertical displacement of the particles, a shaking. Then it'll also be lateral movement, because as the bulge of the tide goes up, the water has to come in from the sides. You can go to any mall and buy 2 little pieces of glass with sand in between, multiple color layers of sand, flip it over and make hundreds of layers in a few seconds. I mean, kids play with them all the time. And it's not always sorted by larger on the bottom and smaller on the top. You can get smaller and then larger layer and then smaller and then larger. You can get multiple layers simultaneously. So I think you need to watch my video number 4 on our seminar of drdino.com. That might help you understand a little more about hydrologic sorting, which can do all sorts of crazy things.
Well, as it happens, I actually did an experiment. It was one that you recommended in your seminar, and similar to what you just talked about with the mall, where I took different types of dirt, I took different types of rock, I took different types of vegetation, I poured water all over it, put it in a jar, shook it, and I even did this on video in one of my videos, and I left it. And it did not sort into these different layers that are promised by creationists. What I instead got was the graded bedding that I was describing to you just now. Bigger at the bottom, smaller at the top, no sorting by composition.
Well, in Colorado, just north of Denver, I think it's north of Denver. Yes, north of Denver. The Navy has a sedimentation tank, a huge, because they're concerned about where do we hide our submarines, because the bottom of the ocean changes all the time because of sedimentation. They've done extensive experiments on this. What kind of sedimentation happens based on water currents and water temperatures, even stuff like that? What would cause the depositional rate to change? And I think you'll find multiple layers can form simultaneously due to lateral movement of the sediment load. And they show pictures of it happening with glass sides on their tank. So I show some of that on my video number 6 of the Hovind theory, what happened during Noah's flood. But I'm not demanding all the taxpayers pay for Noah's flood story to be taught. I think it's logical and reasonable. I think it does explain the sedimentation.
Okay.
But I'm not asking for it to be taught at taxpayer expense.
Okay, I don't think that it... Okay, fine, let's move on.
You want to, okay, good. I know we're kind of crunched on time a little bit here. Joe Sansi's question, not really physics related, but it actually is an interesting question. He says, how can he, meaning you, Ken, this is directed to you, how can Kent predict what God would design without access to God's intentions? If he says he can access them in the Bible, does he realize that would be begging the question?
I didn't understand the first word. I can't hear you the wording. How can I predict God's intention by reading what now?
Let me read it again. How could he predict what God would design without access to God's intentions? If he says he can access them in the Bible, does he realize that would be begging the question?
Well, I think I would quickly agree that I admit mine is a religion. I believe God designed things, and I believe he wrote a book and told us about it. I don't think we yet today understand all of God's design. We have not even scratched the surface on understanding the DNA code. And the complexity there, not only the chirality in the spiral molecule, but even in the lapping of it, the overlapping and folding of it, how it transfers data back and forth. If it takes really intelligent scientists years and years and years to begin to scratch the surface of understanding the code, I think it's logical to say somebody wrote this code. Somebody really smart wrote this DNA code. So I don't know that I can predict everything, but God told us in his word, and it may be begging the question. I admit that's not something I believe. I wish the evolutionists and atheists would admit that they believe a lot of things, but they don't. They want all of us to pay for this to be taught, and I resent that.
Okay, so you are acknowledging that it could be begging the question, or is begging the question.
Well, I don't know that I begged the question. I said I believe this because of the evidence of the incredible complexity. I don't understand everything going on inside of a computer. I don't have to. I believe somebody made this computer. I can look at it and say, wow, this was designed by somebody really smart. I can look at a cell and say, wow, this was designed by somebody really smart. I don't know how he did it or why, and I don't think anybody does understand even cellular respiration and all the different things that happen in the cell. I don't think there's a person on the planet that understands all about one cell. They're finding new things all the time, but I think it's evidence of an incredible design.
Let me ask the next question to KC. This is kind of an extrapolated question that I got from Landon Kurt Knoll. He a brilliant mathematician that we know. He was talking about Cepheid variables, and that Cepheid variables no longer used for measurements. But can you kind of explain how we would use a Cepheid variable or standard candles to measure distances and relate to that on how the age of the Earth must be in relationship to that?
Cepheid variables, I don't remember much about. If I remember correctly, it involves there's a sinusoidal relationship between the speed with which it rotates and the amount of light that we get. So I don't remember much about Cepheid variables, but I do know that they can be used in order to measure these distances. With standard candles, you have type 1a supernovae. These are a supernova of a specific type. It's what you get when you have a binary star system and they end up crashing into each other. Sorry, can we get Kent muted for a second? I'm getting feedback again. Yeah, sorry about that. So you have this binary star system, and you end up with a supernova. And we find that there is a standard brightness to it, regardless of what the distance is. We saw, I believe the nearest one was about 10 parsecs away, and that's sort of used as the baseline to determine the absolute brightness. So you take this absolute brightness, how bright it would look from 10 parsecs away, and you compare it to the apparent brightness, how bright it appears to us from Earth. And as it turns out, there is a relationship between the distance an object is and how bright it appears from varying distances. So, if you have a candle that's 2 feet away, it shines with a certain brightness. If you have a candle that's 10 feet away, it's a little bit more dim. If you have a candle that's 100 feet away, it's even more dim. But there is a relationship between how dim it is or how dim it appears and what the distance is. And so you can take these two different brightnesses, you plug them into an equation called the distance modulus equation, and you come out with the distance away that it is based on its brightness.
Okay. I'm trying to get more questions from both sides. I'm going to take kind of as they come, whether they're pertinent to this particular debate or not, because we're kind of limiting on the questions, and I thought we'd have more. But
Kent, by the way, you're muted, so maybe if you're talking during this time.
Yeah, you're going to have to unmute. Let's see. Tyler Durden had asked, Kent, he wants to know if you would actually give a more formal definition from a young Earth creationist perspective of the word kind. And you're going to have to unmute. Kent?
Okay, there we go. Okay. The definition of the word kind in the Bible is very simple. God said they will bring forth after their kind. I think bring forth quite obviously means produce offspring. Animals that are able to mate and produce offspring are the same kind. A pine tree and an oak tree cannot produce anything. The seed won't mix. A sheep and a banana cannot mix. A dog and a banana cannot. They're obviously a different kind. Now, is exactly where the border is in every case, I don't know. But the Bible, the answer to the question is, can they bring forth, or could they originally bring forth? The Chihuahua and the Great Dane obviously came from a common ancestor that was able to bring forth, but there seem to be at the extreme limits of that kind. Great Dane, maybe somebody may get a dog bigger than a Great Dane someday, but I promise you, they will never, ever, ever get one as big as Texas. There's a limit. So the changes that we see within the kind of them bringing forth are, to me, an indication of the limits that God put on it. They get dogs as small as a Chihuahua. They will never get one as small as a flea. But there are animals as small as a flea, like the flea. So the animals bring forth after their kind. So bringing forth seems to be the biblical classification of how do you tell if it's the same kind? Can they bring forth? Horses and pigs cannot mate and bring forth anything. They're a different kind of animal.
Casey, do you want to maybe address that as well?
Yeah, Mr. Hovind, I hear that you got married recently.
I did.
So I want to congratulate you on that. I'm wondering, are you and your new wife capable of bringing forth?
Who? Georgie White?
Are you and your new wife capable of bringing forth?
We're both, no, we would have been 30 years ago.
So you're not the same kind then?
Well, no, we could have brought forth. We're both human, male, she's female, but she is past the age of childbearing, so yes.
But Kent, I thought that the definition of the same kind was two things they could bring forth. Or should we adjust the definition maybe?
If they can bring forth, we are the same kind. We are both human. We did bring forth children. She has 5, I have 3. And so, yes, and guess what? They are humans. They are also human being, and they brought forth, and they're still humans. We're waiting for them to make something else, but so far, only humans have come from the unions that we've had. So
but you and her did not bring forth.
Are you serious about this?
Not together.
Casey, are you this desperate? Come on, use your head, son. This is silly.
Well, what I'm saying
Yes.
is the definition. It's part of a more general point, because the definition of kind is vague and open to all kinds of equivocation and goalpost shifting. So normally, when I get into this kind of argument over kinds, the creationist will equivocate whenever I bring up things like ring species. Yeah, but they're still the same kind, even though I violated their definition of it. So I decided to play my own little game. I'm using your definition of kind in a manner that, well, you wouldn't approve of. The problem with kind is that, as other people have indicated, it's too vague. You can play all kinds of games with this, like I just did. So let's say, I'm sure you've had this example brought up to you with the Encetina salamander with ring species. They're no longer able to bring forth, and yet you say they're still the same kind because they're both salamander. Well, how do you know they're salamanders? Because they're the same kind. How do you know they're the same kind? Because they're both salamanders.
Would you say that the ring species, and to define this for the audience, if you go a ring around a mountain or something over a period of generations, or a ring across an impenetrable barrier like Colorado River, a barrier for the squirrels, they can't cross the river. They now have the Kaibab squirrels and whatever the other one's called. Okay, so they're still squirrels. They're still recognizable as squirrels. And you're saying the fact that we can now get a variety that is no longer interfertile with each other, like the horse, the horse and the ass produce a mule, which is sterile, but they did produce. So the fact that my parents did produce me, and my wife's parents did produce her, so that there was bringing forth right there.
Yeah, but now you've introduced this new thing into the nomenclature of varieties. What is a variety? I'm guessing this is a subset of kind?
Well, the Bible only uses the word kind or sort, the word sort. God told Noah in Genesis 6 and 7 to bring them after their sort, 2 of each kind and 2 of each sort of animal. If I told you to go into the shop and pick up 1 of each sort of tool, you would get a hammer, a pounding tool, a cutting tool, a grinding tool, maybe. I think anybody could organize their shop by kinds. We have all of our screwdrivers in one place, our pliers in one place. It's pretty obvious in most cases how they fit in. Now, there may be some unusual animals like a platypus, which are totally kind of its own. I mean, I don't know what all the kinds are. I'm not asking my theory to thought.
I don't think that these terms kind and sort and variety can be used intelligibly because of how vague and how much they can be shifted. Let me use this in atomic physics. Let's say that I was to meet a person and they told me that they don't believe that one kind of element can't turn into another kind. It's impossible, they say, for one kind of element to bring forth with another element to produce a new kind of element. So I tell them, okay, well, what about fusion reactions? You get 2 hydrogens, you get them up to a really high temperature, you bring them together, and you end up with helium, and there's a nuclear reaction right there.
Sure.
And I've met their definition of a change in kinds. One kind of atom has turned into another kind. I presume that I've met their definition because I define different kinds of atoms in terms of the number of protons that they have. And they say, no, that's not a change in kinds of atoms. That's not a change in kinds of particle. You see, a change in kinds of particle would be something like an atom turning into an electron. And of course, those silly nuclear fusion believers, they believe that this sort of crazy jump happens. And I tell them, no, they just believe that different types of atoms can fuse and undergo fission to produce different types of atoms. And they say, okay, fine, but that's micro nuclear reactions. You get where you see where I'm going, Ken. You can.
They did not mate and bring.
You can play this kind of game across a wide variety of disciplines, and you can change the definition of kind, from atom to particle to whatever encapsulates as much as possible if it allows one to avoid.
Right, let me make 2 points here. Number one, can you give us a good solid definition of species? Are a horse and a zebra different species? Can they mate and bring forth? How do you define species? Number two, I'd like to point out, I'm not asking for my theories about kind to be taught at taxpayer expense. You are.
Well, I'm not a biologist, but from what I understand, a species is defined as 2 organisms who are similar enough genetically in order to produce fertile offspring.
Exactly what I said. They bring forth after their kind. Okay.
Okay, but they need to be genetically similar enough to be able to do so in principle. So let's say you have a couple of elderly human beings. They are genetically similar enough to be able to produce fertile offspring, but they're just old. They're not able to do that anymore. It has nothing to do with their genes.
But you can still try.
Well, I mean, good luck. But whatchamacallit?
Okay.
Let's say you have a case where you have an infertile person, right? For some reason, she doesn't produce ova. In this case, they are genetically similar enough to be able to reproduce in principle, but because she's infertile, they can't produce. They can't produce a member of their own species. But when you have something like the Encetina salamander, and you have these ring species, what you have is a genetic divergence. You have these organisms that are not too infertile and not too old to reproduce. They can reproduce with other members of their populations. But when you bring these two populations together, they're not able to reproduce with each other. So you do have a speciation event. They have genetically diverged too much to be able to reproduce, even in principle.
Okay,
so
that's a great example. Let's take these salamanders that are now genetically different and cannot reproduce. Is that evidence that salamanders and bananas are related? Is there a limit to how far these salamanders can go? Can they gradually turn to a banana if you gave them billions of years? Or is it always going to be a salamander of some kind?
Are you asking if there's a kind of natural biological limit to the extent to which genes...
Yeah, is there some kind of... Right, is there a biological limit? As far as what's observed, they're still salamanders.
What we observe is that there doesn't appear to be any barrier. Given an infinite amount of time and allow for an infinite number of generations to pass, there's no good reason as to why allele frequencies couldn't change to an infinite extent.
And there's your God. There's your God right there, Casey. Time can accomplish what we do not see. It can happen if we give it enough time. You believe that? I believe in the beginning God did it, and you think just enough time can accomplish the same thing. You think humans were squeezed into this little tiny dot, and it exploded, and all of the molecules in my body, and the fact that if that is true, then how can you even trust your own thinking and reasoning processes? Because your mind is nothing but a bunch of matter that came from a hot dot. You don't even know if you're thinking logically.
That's more of a philosophical point. But let me tell you about another so-called religion of mine. It's called the religion of believing Pluto is in orbit around the sun. It's a religion because we only discovered Pluto about 90 or so years ago, and yet we can say that it has an orbital period of about 243 years, and we can plot out its exact trajectory. And so we say, given enough time, Pluto will complete a cycle around the sun, even though we've never observed it. And that, by your account, should count as a religion, because, not enough time has passed and we've never observed a complete cycle for Pluto. This is nonsense, Kent. You can absolutely extrapolate, and there's, I'm sorry, but this reeks of desperation.
No, I'm not believing. I'm not desperate at all. I'm having a wonderful time here. I think there are different kinds of knowing, different ways of knowing. They've been digging into the hillside in our property to get material to build a dam on our property for the lake. They have dug in about 30 feet, and they've hit clay the whole way. I think it's reasonable to extrapolate. If they dig in another 5 feet, they'll continue to hit clay. That is something I believe is logical and reasonable based upon the observable evidence. That is very different than believing this clay came from nothing, from an explosion in a big bang. So there are different ways of knowing things. I think we can dig a hole down 5 feet and hit gravel and say, well, if I move over here, I'll also hit gravel. That's correct. That is extrapolation based on observable data. What you are doing is not extrapolation based on observable data. Nobody ever sees the things happen that you believe happened. It's something, that's why it's a religion. It's a religious belief.
It's not a religion. Ken, if you want to believe that, you can, like I said, you can keep saying it's a religion, but I'm telling you, we accurately make these predictions based on these models. Like I said, with the Big Bang earlier, there was an accurate prediction of the cosmic microwave background radiation. There are accurate predictions of all sorts. And same with evolutionary theory, we're able to predict that such things as ring species are capable of existing using this theory. There are all kinds of other things as well, but I'm not a biologist, so I can't name all of them off the top of my head. The point that I think everyone should take away is these so-called evolutionists, we're capable of accurately predicting future data. The creationists are not. What they have to do is they have to look at data that has already been gathered and try to explain it in an ad hoc manner. And sometimes this happens in a manner where there's this Omphalos argument where God only makes things appear to be the way that they are. And then this is supposedly put on par with our predictive accuracy and our predictive capabilities. It's an insult to the scientific enterprise. We do real work. Creationists don't. And
that's an insult. That's an insult and below the belt and unnecessary.
No, it's
So
true, though.
nobody, in other words, we have to believe that we all came from nothing to be able to be
When did I
qualified
say
as a
that?
scientist.
You keep saying that I say these things, but you fail to qualify. When did I say this?
Okay, we all
I don't
came
think
from this tiny
I don't
spot.
think that I.
Okay, I'm sorry. We all came from this tiny spot of energy, and therefore we don't even know that we have a mind to even be having this discussion, because we're actually nothing but a bunch of energy turned to mass. Is there anything? Is there such thing as a spirit or a soul, or are we all just animated meat?
Are we all just animated meat? I mean, this is more of a philosophical question than it is a question of what science has to say. The science only deals with the material and with the natural world. You know, by definition, if you want to introduce this other kind of substance, this qualia or this supernatural, dualistic type of thing, that lies outside of the scope of science. Now, let's say,
well,
I think you have a more
prediction.
Sorry?
No, you said predict future data based on the Bible and based on the creation model. I can predict that the God who created it is going to call everybody into judgment one day. We're going to be judged for every word we've ever spoken, every thought we ever thought, every deed we ever did. Now, our time is up. It's been an hour and a half, which is what they said to go for. But I predict there will be a judgment one day, and I predict you and I will stand face to face before God, and he will judge us for everything we've ever said, thought, or done. I think I'm ready for that day because I've got a substitute to pay for my sins. I hope you do too.
Regrettably,
you want to wrap it up, guys? Then
really quick, let me just respond to that
yes,
really quickly.
Absolutely, please.
Regrettably, in science, this is what we refer to as a non-falsifiable model. There is no piece of evidence, even in principle, that would satisfy Mr. Hovind in order to have him accept the contrary. Now, that's fine. You can have whatever spiritual beliefs you like. You know, that's your business. But when you use those spiritual beliefs to intrude into the scientific enterprise and start coming up with all these ad hoc models that contradict what scientists doing real work do, and you start pushing for these scientific theories to stop being taught in public schools, that does cross the line. So that's why I'm here to debate. That's why I'm here to argue against these things, and that's why I'm here to point out that creationism is not capable of producing falsifiable predictions.
Thank you, Casey. Kent, do you want to have anything else before you have to go?
Well, no, you said we're going to have a quick closing or something?
Was that your closing, your initial closing, or did you have something else you want to add?
Oh,
I just want to make sure you get equal time.
Yeah, I believe that all the evidence points to the Bible being exactly correct, that the earth cannot be billions of years old, and that man was created instantly, fully mature, and that we've always produced, humans have produced humans and dogs have produced dogs. There are no known exceptions to this. If somebody wants to believe humans and dogs are related, that's certainly that's their privilege, but it's outside of science, observational science. It can't even be extrapolated. The gene code is so wildly different. And I predict there will be a judgment one day, and I'd like to see everybody get ready for that. If you don't know Jesus Christ as your personal Savior, I would suggest you start checking. I predict the universe was created by God, and he gave some laws. Don't lie, don't steal, don't cheat, don't commit adultery. I mean, they're spelled out in the 10 Commandments, Exodus 20. And I predict you two guys whom I've never met have broken some of those laws, and I think you're going to be in serious trouble when you stand before the Creator. And you can stick your finger in your ears and go walking through the minefield if you'd like. But it's going to come back and bite you, and I feel sorry for you.
Okay. Thank you, Ken. Again, I want to thank both you guys for being here today. I want to thank all the people watching. I want to remind all of you to subscribe to both King Crocoduck and Ken Hovind's channel, regardless of whoever you thought won. Also to subscribe to my channel, Steve McRae, to watch and or participate in these types of debates and discussions, which we'll be having many more on to come. It's easy to join the Great Debate community. Just click the link in the video description below and hit join. I'll be having a debate after show on my channel sometime between now and 8 p.m. Pacific Daylight Time, probably sooner, probably about 7:30 because we ended a little bit earlier than expected. Hopefully a lot of special guests will be there, including PZ Myers, maybe Landon Kurt Knoll. It's open to anybody to join, regardless, again, of who you thought won, and we would love to have you come join us. And with that, I thank you all again, and we'll be seeing you next time.